Hi everyone, this is Pre-Algebra topic 9, probability. So in topic 9, you will see 7 lessons total. We're going to start with understanding the likelihood and probability and what that means. And then we'll do more understanding lessons of theoretical probability, experimental probability, and then we'll start using probability models and determine the outcomes of compound events and probabilities of compound events. And then finally, we'll simulate compound events. So some topic vocabularies that are very important are listed here: compound event, experimental probability, outcome, probability, probability model, relative frequency, sample space, simulation, theoretical probability. So as a whole, we'll think about how we can investigate chance processes and develop, use, and evaluate probability models. So you will see a lot of real-world examples in this topic. If you skip through some pages, you will see get ready parts. We will review what we know about this topic and see if we know the things that we are supposed to know before we started, okay? So first, these are vocabularies that you should know: equivalent, frequency, diagram, and ratio. So let's fill in the blanks and figure out which goes where. So see if you can figure it out by yourself and check your answers as we go, okay? First, a or an blank is a drawing that can be used to visually represent information. So it's a drawing and it's going to represent some information. Is it equivalent? That's an adjective, so no. Frequency? Diagram or ratio? Diagram is a drawing that can be used to visually represent information. Okay, number 2, the number of times a specific value occurs is referred to as. So more number of times you see the same number, you say it appears frequently. So that's going to talk about frequency. Okay, and then a or n blank is a relationship between one quantity and another quantity. So relationship, you're comparing one to another quantity. It's a, so we got rid of these two. It's ratio. All right, and last but not least, quantities that have the same value are equivalent. If they have the same value, it's called equivalent value or expressions. So let's look at operations with fractions. Do you remember how to add, subtract, divide, and multiply fractions? So let's check if you remember them. And ratios, order fractions and decimals. So stop the video again and see if you can solve them by yourself. And come back when you're ready for answers. Okay, are you ready? So let's look at number 5. That is number 5. You're solving for x. It'd be great if you could show your work, and so that we could see if there's any step that you're missing, right? Or any step that you misplaced a number or made a mistake on. So firstly, you want to isolate the variable, right? So in order to do that, you want to undo other terms. So you have a positive 2 over 5 here. That means you're going to subtract 2 over 5 on both sides. So you get x is equal to 1 minus 2 over 5. 2 over 5 minus 2 over 5 is 0, so you just have x, okay? And then how do you subtract a whole number and a fraction? You make the whole number a fraction. So make 1 into 5 over 5 so that you can easily subtract 5 and 2. You get 3 over 5. So x is 3 over 5. Okay? Same thing, x is equal to 2 to 5 times 1 over 3. That means if you're multiplying a fraction with a numerator of 1, what does that mean? You're basically dividing it by the denominator, okay? So if you multiply 225 is a whole number. If you make it a fraction, that's over 1, right? So 225 times 1 is 225. 1 times 3 is 3. You see that? So it's just 225 divided by 3. So if you divide it by 3, you will get an exact whole number of 75. X is 75. All right, number 7. You have 1 is equal to 1 over 8 plus x plus 2 over 8. So you're going to combine the like terms first so that you can simplify the right side of the equation. Thankfully, the denominators are the same. So you probably got 3 over 8 plus x as your next step. And then you're going to subtract 3 over 8 on both sides. That means 1 wants to be 8 over 8 so that you can subtract the fractions here. And then you have an x isolated on the right side. And then 8 minus 3 would just be 5. And so your x is equal to 5 over 8. All right, check your answers and see if you got all of them correctly. If you didn't, please go back and check your steps and see where you made the mistake and redo it. Because you really want to know how to do operations with fractions before you get into the probability, because we're going to deal with a lot of equations, okay? Ratios. You also need to know ratios. Write each ratio in fraction form. Then write the percent equivalent. First, you need a fraction, okay? 72 out of 96 basically is 72 out of 96 like that, okay? And then you can simplify that into what? You're going to divide both of them by 24, okay? To get, that's the the greatest common factor, to get 3 over 4, okay? And that will just be equivalent to 75%. And if you don't remember how to change the fraction into a percentage, you first have to literally divide 3 by 4 and then see what you get in decimal. And then you get 0.75, change the decimal into percentage, okay? That's a quick review, but if you still don't get it, that means you really need to go back and study again. Number 9, 88 out of 132. So that's basically 88 over 132. You want to simplify that fraction so that you can easily convert that into a percentage, right? So you're going to divide both of them by 44. Divide by 44, divide by 44. You may not know what a greatest common factor is just by looking at it. So if you want to divide it by 2 first, you can keep dividing it by the same common factor until you get to the least factor, okay? You don't have to be able to see that the greatest common factor is 44 right away, okay? That's fine. Whatever works for you. So 2 over 3 is the most simplified fraction. You should still get the same fraction, okay? And then divide 2 by 3 and you will get 0.66666 repeated. And so you can round it up, but if you want an exact form, which is what we usually prefer in mathematics, you leave it as fraction, okay? So 6.66 repeated could just be 66.67%, but where do you round up, right? They didn't tell you. So I'm just gonna write fraction, 2 over 3%, okay? But if you don't know how to convert decimals, repeated decimals into fractions right away, it's fine if you round it up, okay? We're just checking if you can remember these skills before we start the topic. Number 10, 39 out of 104. So that's 39 over 104. If you simplify that fraction, is 3 over 8. And that is equivalent to 37.5%. Okay, now I'm just going to go through answers because I've already explained how to do that in numbers 8 and 9. Number 11, 23 out of 69 is 23 over 69. And that is equivalent to 1 over 3. And in percentage, that should be 33 and 1 over 3%. Or you can do 33.3%. Okay? 52 out of 208 is simplified to 1 over 4. And 1 over 4 is just 25%. 1/4 of 100% is 25%. And 25 out of 200, you can simplify this to 1 over 8, or you can just divide it by 2 so that you get a denominator of 100 and you get 12.5 here. Why do we want to do that? Because anything over 100 is easily converted to a percentage with that numerator. Okay? That's what percent mean by definition. All right. So check your answers. If you didn't get everything correctly, then you need to go back and check your mistakes in your steps. Or you need to go back to the entire concept and relearn it if you feel like, oh, you just don't know how to do any of them. All right, the last part, order fractions and decimals. Plot the following fractions and decimals on the number line. So we have a number line that has 0 through 1 broken down, right? So if you divide that by half, that is 1 over 2, or 0.5, right? And then 1/4 of that is 0.25, because that's 25% of 100%. 3/4 is 0.75, right? So look at 0.7. 0.7 should be a little bit less than 0.75. So why don't we divide each of these blocks into 5, right? Because each of them will represent 25 blocks, right? So if we divide each of them into 5 different blocks, then we know that each of them represents 0.05, right? So let's divide that 1, 2, 3, 4, and 5. Okay, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay, and then that's 0.05. That's 0.1, and so on. Okay, so 0.7 should be, that's 0.1, 0.2, 3, 4, 5, that's 0.5, and 6 and 7 right there. Okay, this is 0.7. There we go. And then 1/3 of this. 1/3 in decimal. What is 1/3 in decimal? 0.3333 dot dot dot. So 0.3 is right here. 0.35 is the next one. So 0.333 repeated. In percentage, that would be 33%. So it should be around here. Okay, so that would be 1 over 3. Right, and then 7 over 8. Where does 7 over 8 go? What is 7 over 8 in fraction or in decimal? You can either convert this into decimal and get 0.875 and then plot it. But if you look at the graph, it's already divided into 4 if you look at the bigger division lines, right? If you divide each of them by half, so like I'm going to divide this by half like that, I'm going to divide that by half, that by half, and that by half, okay? And so that's, as a whole, from 0 to 1, now it's divided into 8 pieces, okay? If you look at the bigger division lines, bigger tick marks. So then you just count 1, 2, 3, 4, 5, 6, 7. And then 8 over 8 is 1, right? So this one is 7 over 8. Okay, and then 0.4 goes, you can count your decimals. That's 0.1, 0.2, 0.3, and 0.4. Okay, keep track of your check marks. And then 0.125, so 12.5%. 0.1 is here, 0.2 is here, and the middle is 0.12.5 exactly, because 0.125 is half of 0.25. Think about percentage. That's 25%. 0.2125 is 12.5%. 12.5% is half of 25, right? So it's one of the bigger marks, tick mark we divided. So it's 1/8. 0.125 is actually 1/8 of 1. So, but please make sure you write the original numbers that are listed. Don't change your numbers, okay? When you plot the following fractions and decimals on the number line, you need to plot the given numbers. All right, 5 over 6 is what? We haven't divided them into 6. So you can use decimals and figure out that 5 over 6 is equal to 0.83 repeated, right? So you can count 0.1, 0.2, 0.3, 4, 5, 6, 7, and 8. And that's going to be 0.85. So 0.83 repeated should be closer to 0.85 than 0.8. So it should be around here. Okay, that's 5 over 6. Okay, so in order from least to greatest, you can easily see that 0.125 is the least out of all these, and then 1 over 3, then 0.4, then 0.7, then 5 over 6, then 7 over 8. So if you have decimals and fractions all together and you want to compare them, plotting them on the number line is a really good strategy. Okay, so that is a good review of what we learned before topic 9. And that's just the first page. Second page, we're going to get ready to get started on topic 9. So we're going to think about topic 9 and sort the vocab words into categories. Now, we haven't learned the vocab words yet, so this is just a preview, okay? So let's look at compound event, probability, simulation, event, probability model, theoretical probability, experimental probability, relative frequency, outcome, sample space. Okay, what kind of categories do we have here, right? We want to figure out if some words fit in the same category. What are some categories, like bigger idea that you see in those vocab words? So we see some of the same words, right? What are some words that are repeated? You see probability repeated, of course, and then you have events repeated. So let's start with them, okay? Probability types. Okay, so category number 1 could be probability types. And we can put in theoretical probability. And then we can put in experimental probability. And probability itself is not a probability type, right? So let's leave that. And then what else do we see? We have compound event and then event. Event itself as a definition, right? What would event be, right? What are the categories of them? So we can say types of events, right? And then okay, so we have compound event. And then in this case, we can just say the event would be singular event, okay? But we don't really have to say singular event. Event is just event. So we can put compound event and event together as a different types of event, okay? And then everything else could just be what? Probability, simulation, probability model, outcome, sample space, relative frequency. Those are just, what are those things? Those are just information that we need, right? Those are going to be information, the visuals, how to represent the probabilities and everything. So we're just gonna say that as a whole thing is data, okay? Information, okay? So we need data in order to figure out some probability. So we can just write down everything else in there. Probability, simulation, and then probability model, and then no, not experimental probability. We have relative frequency as data. We have outcome, and we have sample space. There we go. So those are all data that we can utilize when we figure out some probability and some theories of using these data. All right, so that will be a good preview of topic 9. So hopefully it summarized what you should know before topic 9, and it gave you a good preview of the entire topic. So please wrap up your get ready part, and I'll see you in the next video. We'll start lesson 1.